Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is OCR November 2021, paper 5, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends because they might need a helping hand too. Okay, let's get into it. Question 1, work out 3 4/7 multiplied by 7/10. Right, so we have a mixed number here, or a mixed number and a normal fraction when multiplied together. Now in order to multiply these together, we're going to have to deal with this mixed fraction first. This mixed number first, rewrite it as an improper or top-heavy fraction. Now we can do that by taking the whole number and multiplying it by the denominator. So 3 times 7, that's 21. And then add on the numerator, 21 plus 4 is 25. And then that is going to be our new numerator for our top-heavy or improper fraction. We're going to keep the same denominator, so it's going to be 25 over 7. So 3 times 7, 21 plus 4 is 25 over 7. So 25 over 7 multiplied by 7 over 10. Okay? Right, now, you can just multiply top with top, bottom with bottom, and then simplify, but I always think it's easier to simplify first. So you can look for common factors, top and bottom here, and cancel those out before you multiply. So for instance, I can see a 7 and a 7, so I can divide both of those by 7 and get 1 and 1. Okay, and then in the 25 and the 10, both of those are divisible by 5, aren't they? So I'm going to go ahead and divide those by 5 as well. So 25 divided by 5, that is 5. And then 10 divided by 5, that's 2. Okay? Now that leaves me with a whole lot more simple number to multiply. So now I've got, rather than 25 times 7, I've got 5 times 1, which is a lot easier, isn't it? So 5 times 1 is 5. And rather than 7 times 10, I've got 1 times 2, which is 2. So the answer is 5 halves, or 5 over 2. But notice the question does say or stipulate that I need to give my answer as a mixed number. This is not a mixed number. I need to convert it back, don't I? So how many times does 2 go into 5? 2 goes into 5 twice, remainder 1. So that means the big number is 2 because it goes in twice, and the numerator is 1 because the 1 was the remainder, and we still have the divisor of 2. So that's 2 and 1/2. Question 2a, Asmi is given this question. Write 40 as a product of prime factors. Give your answer in index form. Asmi's answer is 2 times 2 times 2 times 5. Is Asmi correct? Explain your answer. Okay. Well, is 2 times 2 times 2 times 5 equal to 40? That's probably the first thing to check, isn't it? Has he got the numbers right? 2 times 2 is 4, times 2 is 8, times 5, that is 40. So his prime factors do equal 40. They are all prime factors, so you've obviously cancelled it down enough, so that part of it is right. If you wanted to double check that, you could just do a quick fact tree on here. So 40 is 20 times 2, which is, what, 5 times 4, which is 2 times 2. Okay, so they're all primes, aren't they? So you can see that we're going to get 2 times 2 times 2 times 5. So like this part, the numbers themselves are correct. So it's equal to 40. He's got the right prime factors. Now, but the question does state that he needs to give his answer in index form, and this is not in index form. This is what we call expanded form. To write in index form, you would just write as powers. So rather than writing 2 times 2 times 2, we write that as 2 to the power 3. I've only got 1 5, so I'm just going to leave that as 5. So that's what it would be in index form, 2 cubed times 5. And he didn't write that. Okay, so is Azmi's answer correct? It's not quite correct. He has, I assume it's a he, I don't know what Azmi is. He has picked the right prime factors, but he has not written them in index form. Answer should be 2 cubed times 5. Okay. Now I always write far too much on these lines. You know, if you look at the mark scheme, they'll kind of take fairly minimal answers. But I don't know. I just like to write it properly. So that's kind of how I respond to that. You probably get, let's say, you could probably just get away with the answer should be 2 cubed times 5. Part B says find the value of x where 1 over 16 is equal to 2 to the power of x. So we've kind of got an equation in x here, but x is the power of 2 there. It makes it kind of hard to isolate. I think what I'm going to do is I'm going to just start with the equation they've given me, and I'm going to see, well, you know, I can spot 16 as a power of 2 straight away. So if I rewrite 16 as a power of 2, I can change the left-hand side to look a little bit more like the right-hand side. So 16 is 2 to the power of 2 for a 16. That's 4, isn't it? 2 times 2 times 2 times 2 is 16. So that is the same thing as 1 over 2 to the power of 4. Okay. So we're making progress. It looks a little bit more like what we've got. And then 1 over 2 to the power of 4. If you've got 1 over something, that's the same thing as a negative index. If I write it as 2 to the power of minus 4. So 2 to the power of minus 4 is 1 over 2 to the power of 4. So then I've got this, haven't I? Okay. And then this expression, this is the same as this, and they're equal. So ergo, this should be the same as this, shouldn't it? So I can say then that x must be minus 4 for that to be true. Question 3. A car mechanic has a tin containing 5 litres of engine oil. Each week they use 450 millilitres of this oil for their vehicles. The car mechanic says, after 9 weeks I will have used over 80% of the oil in this tin. Are they correct? Show how you decide. Okay. So first up, we've got 5 litres in the tin to start with. Now each week we are consuming 450 millilitres of oil. Now notice the mixed units here. So the first thing I'm going to do is convert everything into the same unit. Now I think it's going to be easier to convert 5 litres into millilitres. Now 1 litre is 1,000 millilitres. So 5 litres is going to be 5,000 millilitres. So that's my starting amount of oil. Okay? Right, so the car mechanic is saying that after 9 weeks he's used over 80% of the oil in the tin. Okay? So if he's spending 450 millilitres of oil a week, and after 9 weeks, how much oil is that altogether? I think that's what we need to find out. So I'm going to work out total oil consumed. Now that's going to be the 450 millilitres of oil that is consumed each week times by the number of weeks, which is 9. Okay, Now 450 times 9. Now I know that 450 times 10 is going to be 4,500. So times 9 is going to be 450 less than that. So 4,500 take away 450. That's 4,050. Okay. Now if you're struggling with that, then you could always, you can do it by long multiplication and work it out that way. So anyway, that's 4,050 used. Now, is that over 80%? So that's the total oil consumed. Percentage consumed. That's going to be the amount of oil that we used up divided by the total amount of oil. Okay? So is that going to be more than 80%? Okay? Now to get that, I think what we need to do is convert this into a fraction over 100, so we can rewrite it as a percentage. Well, I can see that I can scratch a 0 off the end there straight away, top and bottom. So that's going to give me 405 over 500. And then if I can divide top and bottom by 5, then I'm going to get a fraction over 100, then, aren't I? So if I just say that's the same thing as 405 over 500, and then if I can divide top and bottom by 5, I'm going to get a fraction over 100, then, aren't I? Okay, so I don't know what the numerator is yet, but I know 500 divided by 5 is 100, so that's what I'm aiming to do. So what is 405 over divided by 5? Let's just do this over here. So 5s into 405, 5s into 4 don't go, 5 into 40, that goes 8 times, remainder 0, and 5s into 5 go once. So that goes in 81 times. So 405 divided by 5, that is 81. So 81 over 100, what is that as a percentage? That is 81% then, because it's over 100, that's what a percent is. So that's 81%. So after 9 weeks, I have used over 80% of the oil in this tin, said the mechanic. Is the mechanic correct? Yes, we've used 81%, which is over 80%. So I can say 81% is greater than 80%. So the mechanic is correct. Okay, so we've interpreted the answer. We haven't just worked out the answer is 81. We've interpreted that answer. We've said 81 is greater than 80, and then we've concluded that the mechanic is correct, and that will earn us all the marks. Question 4. The table shows the marks obtained by 10 students in spelling tests in January and February. So we've got the mark in January and February given in the table. The marks of the first 6 students are plotted on the scatter graph. I assume that's the first 6 of the shaded ones. And then part A says plot the marks for the remaining 4 students. So it's these here that we need to plot, isn't it? These ones. Okay. Now the mark in January is the mark along the bottom of the scale, and the mark in February is the one up the y-axis. So that first one, 70, 86, we're going to have to plot a point at 70 along and 86 up. So scanning along the axes to 70 and then up to 86. Find that hard to see on this thing. Let me just get a ruler out to help me. So I'm going to kind of put it at 70 and read up to where I need to get to. Or read across from where I need to get to, and I know where to stop. So then 86 on the other side is going to be, whoa, this is hard to read at this scale, about there. Okay, so there's my first point. 44, 60. 44, 60. Well, 44 is there, and 60 should be a little bit easier to read. It's there. Okay, make that a little bit bigger. And then 37, 48. So 37, 48. It's going to be 2 under 50. It's going to be there. It's a bit high, that one. And then 38, 50. So it's slightly to the right of that one, and a little bit up. So a bit of a cluster going on there. It's going to be there. Okay, so there are my 4 extra points. Describe the type of correlation shown in the scatter diagram. Well, apart from a couple of points, they look pretty darn in a straight line there. If you look, kind of like that. That's how I probably do my line of best fit through those. So can you see? Well, you can see all the points are like under my ruler now, apart from one. So it's definitely kind of going up from left to right. Now we call that sort of correlation positive correlation. If I was to draw a line of best fit, I think my line would go something along that sort of line. Okay, so definitely positive correlation there. I'd say it's actually quite strong positive, but it doesn't ask me to talk about the strength, so I'm just going to write positive correlation. Okay, on the scatter graph, circle the student that made the greatest improvement in their marks from January to February. Okay, I think they're going to be the person most significantly over the line, aren't they, of my best fit. And can you see that this guy over here, whoever he is, he did really well, didn't he? This guy. So he scored 30 in January and 66 by the looks of things in February. So he did great guns in as a kind of improvement, gone up about 36 marks. I think you'd probably be happy if your mock to final went up by 36 marks, wouldn't you? You'd be pretty chuffed about that. Right, so he's done really well. I've circled him or her. Work out the percentage change in the student's mark from January to February. So I said that the January mark was 30. I probably can see him on the graph here. It's this guy here, isn't he? 30, 66. So January mark was equal to 30, and February was equal to 66. Okay, so we want, let's just do a little triangle, final, original, multiplier. So FOM, you've seen this triangle before? I kind of do all my percentages this way. So final is what he got in February, isn't it? That's 66. Original is what he had originally in January. That's 30. Now the multiplier is the kind of the percentage change, and that's actually what I want to try and find. I want to find out what M is. Okay. So covering up the thing I want to find M. Put my thumb on it there. Then my multiplier is equal to my final over my original. So multiplier is equal to final divided by original, which in this case is going to be 66 over 30. Now, I want that as a percentage. How am I going to get that to be a percentage? Well, I can see that 30 and 66 both divide by 3. So if I divided them both by 3, I would get that is equal to 22 over 10, which is equal to, if I times it both by 10 now, that's 220 over 100. Okay, so, and that as a percentage is 220%. Okay, now 220% is a big increase, isn't it? So remember, he started with 100%, and now the percentage changed then. If he's now got 220%, that means he's actually gone up 120%. So therefore, increase is 220 less 100, because you always start with 100%, is 120%. Okay? Part D says another student, Kai, scored 79 marks in the January test but was absent for the test in February. Kai says, I could use a line of best fit on the scatter diagram to estimate the marks I have achieved in the test for February. Is Kai's method reliable? Give an answer for your reason. Okay. Now, normally that would be fine, wouldn't it? You would, you can, look up 77 on your January score. You can read up to the line of best fit and across. Okay. Now, the problem that we've got here is that 77 is beyond the range of our data set. Okay. So if you have a look where our points are on the x-axis, then our first value is down here at about 26, isn't it? And points go all the way up to 70. What was the last week? Yeah, we plotted 70. That was the highest one we plotted. So I went a bit far there. Let's just do that again. So we went up to about 70. Now, so if we're looking at 77, we're beyond the range of the data that we've got on the table. Okay. Now, after the last point, we can only assume that things are going to carry on the same way. We've got no evidence to suggest that it definitely does. Okay. So when you're looking up a value within your range of data, that's called interpolation. Okay, so if I look up values here, this would be interpolation or interpolation. Okay, so between here is interpolation, but beyond those endpoints, we have what's called extrapolation, and that is not so reliable because you're just assuming things continue as they do. You've got no evidence for it. Okay, so I'm going to say Kai is looking up values beyond the known data, i.e. extrapolating, which is unreliable. Question 5, work out the volume of this prism. We've got kind of an L-shaped prism here, which is made up of two rectangles pushed together, or two cuboids pushed together. But I was looking at the front face here, which is definitely two rectangles pushed together. You can see all the right angles marked. Okay, so in order to work out the volume of a prism, that is equal to cross-sectional area multiplied by the length or the height of the shape, well, basically the distance between the matching front and back face. Okay, so what we'll need to do is to work out the cross-sectional area and multiply it by the length. Now the length's pretty easy. The length is just that distance there between the front and the back face. So I know that one's going to be 4. What I need to know is the cross-sectional area. Okay, now I'm going to find the cross-sectional area by working out two rectangles and adding them together. Now you've got two ways you can divide this up. You can either divide it up that way, or you can divide it up that way. It doesn't really make any difference. Just because I've done it that way, I'm going to do it that way. So I'm going to call this one area 1 and this one area 2. I'm going to work those out separately. Going to add them together to get the cross-sectional area and then multiply it by 4 to get the volume. Okay, so let's do that then. A1, area 1. Now, how long is that? So it's 6 centimeters from the whole base, but this part here, from there to there, that's 1 centimeter. Okay, so that means that A1 is going to be 5 centimeters in length multiplied by a height of, it's going to be this height here, isn't it? That's going to be that height there, same as that one, which is 1. So that's going to be 1. So that's going to be 5 times 1. Okay, and then area 2, a second rectangle. So we noted that this distance here is the same as that one up there. It's the 1. So that's a 1 by 3 rectangle, isn't it? Okay, so 3 times 1. So this has an area of 5. This has an area of 3. So our cross-sectional area, that is going to be area 1 plus area 2, which is 5 plus 3, which is 8. Okay, so that's my cross-sectional area. So I now know that the volume of the prism is going to be that cross-sectional area times of 8 times the length, the distance between the front and the back face, which is 4. 8 times 4, 8, 16, 32, isn't it? Double again, times by 4. 32 units. It's in centimeters cubed, isn't it? So 32 centimeters cubed. Question 6. Here are sketches of 5 graphs. 5 very interesting looking graphs there. Write the letter of the graphs that represent the following relationships. The first one, y is directly proportional to x. Now, direct proportional means that if x doubles, then y doubles. Okay, so when you plot these on a graph, you're going to get a straight line that passes through the origin. Okay, so it has to be a straight line, so that makes it either B, E, or C, but it has to go through the origin, and there's only one that goes through the origin, and that is C. Now it has to go through the origin, otherwise if you double one, you're not going to double the other. You might double it and add a bit more on. So yeah, it has to be C. Now inverse proportion, inverse proportional is 1 over x, isn't it, or 1 over your value. And the graph y equals 1 over x we call the reciprocal curve. Often when we need to plot it, it has two parts like this and this, but in this case we're just looking at the section up here in the first quadrant, aren't we? That's going to be graph D. So it is D. D is y is inversely proportional to x. Question 7a. Solve the inequality 4 lots of x minus 3 is less than x. Okay, so these you can solve pretty much the same way as you solve equations. I've got a pair of brackets here. I think it's going to be easier to multiply these out first. Sometimes it's easier to cancel the number in the front, but I've got nothing to cancel with that with it here, so I'm just going to multiply it out first. So 4 times x is 4x, 4 times minus 3, that is minus 12, and that is less than x. So collecting the x's on one side and the numbers on the other, I'm going to add 12 to both sides. That's going to give me, they're going to cancel, and that's going to leave me with 4x is less than x plus 12, and then I'm going to take x away from both sides, just like I would with an equation. So I'm going to cancel over here, leaving me 12 on the right, and that is going to be 3x on the left. So I've got 3x is less than 12. Dividing through by 3. Divide by 3, divide by 3, cancel, cancel, leaves me with x is less than 4. Okay, so x is less than 4 is my solution to the inequality. Part B says show your answer to part A on the number line. Now I made it x is less than 4. So now it's strictly less than, so that means 4 itself is not part of the solution. Now I show that by drawing an open circle at 4. If I filled it in, that would imply that x was less than or equal to 4, which it isn't. It's just strictly less than. So it needs to be an open circle. And my inequality is going to go off to the left because x has to be less than 4. So all of the numbers that are to the left of 4 are less than 4. So my inequality I can show with an arrow heading off in this direction. Okay, so open circle at 4 and an arrow pointing off to the left will get you the marks. Question 8a, complete the table for y equals 6 over x, and then we're going to go on to draw it, aren't we? Okay, now most of the numbers we know, there's only one missing value here. It is -2. Okay, because obviously OCR getting wise to the fact that people can just do this on their calculators these days. If you use the table function, you can check out some of my other videos on how to do that. But we've only got one value to find here, so it's not going to be a big deal to do it. So y equals 6 over x. So when x equals -2, then y is going to be 6 divided by -2, then, isn't it? That's going to be 6 divided by -2, 6 divided by 2 is 3. Positive divided by negative is negative, so that's going to be -3. So that value there is -3. So then we've got all the points for our graph. So x is -6, -1, that's a point there. X is -3, y is -2, that's there. X is -1, y is -6, that's down there. X is 1, y is 6, that's all the way up there. X is 2, y is 3, that's there. X is 3, y is 2, that's there. And x is 6, y is 1, that is there. Now I was talking about this sort of graph earlier. This is a reciprocal curve, isn't it? I kind of sketched it for the proportional one we were looking at earlier. So I'm expecting the graph to look like this, and you can see that that's kind of what's going on here. Did I miss a point out? Oh yeah, I didn't plot -2, 3, the one I'd actually found. -2, 3. Let's plot that one in as well. So you can see on this little corner of the axis here, I'm going to have this part of the curve going through there, and then this part of the curve up here is going through there, isn't it? I'm just going to draw those neatly. Well, as neat as I can on this computery thing. So it kind of comes down here through this point. Now don't forget you can turn your paper, which might make it easier for you to plot the points. Through there, and through there. Okay, so yeah, I knew the basic shape of what it looks like, which makes it easier for me to sketch it. Okay, yes, that's what it looks like. It's a reciprocal curve. Question 9, a worker received a 10% pay increase in 2017 and a further 10% pay increase in 2018. The worker says, over these 2 years, my pay increased by 10% plus 10%, that's 20%. Is the worker correct? Work out the correct percentage increase. You must show your working. Well, I can tell you right off that it isn't correct, because this is an example of compound interest, where you kind of, if you add a percentage increase to something and then add another percentage increase, you're not only increasing the original value, you're also increasing the bit you added in the first increase. So the net result is it's slightly more than adding the two values together. Okay, and that's what the compounding effect is of compound interest. So in order to work it out, we could just take a value and work out what that is, because it doesn't say what the amount is. So assume value is £100, say. Okay, so if we had £100 and we increase that by 10%, so in 2017 we're adding 10%, aren't we? So we're gonna add 10%, £100 plus 10%. 10% of 100, that is 10, isn't it? So 100 plus 10, that's going to be £110, isn't it? So at the end of 2017, you've got £110. And then in 2018, that's going to be my £110 plus 10%. 10% of 110, that's 11, isn't it? Okay. So then that gives me 110 plus 11, that is £121. Okay, so you're going to get £121 at the end of 2018. So what is the actual increase? So again, final original multiplier, FOM. So the final is what we got at the end of it. That's £121. So that's going there. The original is what we started with. We assumed it was 100. And the multiplier is what we're trying to work out, isn't it? That's what we're trying to find. So let's cover up the thing we want to find, the M, and then the multiplier then. That is equal to the final over the original, according to my triangle, which is 121 over 100, which as a percentage you can see is just 121%, isn't it? Now we had the same conversation earlier that 121%, if it's 121%, that is an increase of 21% then, isn't it? Because you always start with 100%, so 100% taken off 121 leaves you at 21% it's gone up by. So 10% plus 10% is actually equal to 21% when you're talking about compound interest. Question 10, forces measured in newtons, abbreviated with the letter N. A force of 198.5 newtons is applied to a rectangular surface of length 4.9 centimeters and width 4.1 centimeters. Work out an estimate of the pressure in newtons per square centimeter applied to this rectangular surface. And in brackets it says the formula for pressure is pressure equals force divided by area. Okay, now the key word to this, and the one that the examiners have even bolded for you, is this word here, estimate. And this has a very specific meaning in maths. It means you need to round all your digits off to or all your numbers off to one significant figure. Okay, So I'm going to do that. So the force is 198.5, which is to one significant figure. This is the first significant figure here, isn't it? It's the 1. So I'm going to round off after the 1. The next digit is a 2, so that means I need to... the next digit is a 9. That means I need to round that 1 up to a 2. So I'm going to get 200 newtons to one significant figure. Another way of thinking about it is that 1 is in the hundreds, so you're rounding it to the nearest 100. Okay. The length of the shape is 4.9 centimeters, and that rounds off to one significant figure. This is the first significant figure here, the 4. The next digit is a 9, so we're going to round up again. That one rounds up to 5 centimeters to one significant figure. And then finally, width. We're given that as 4.1, and if I round that off to one significant figure, then the one significant figure is that, the first significant figure is that 4. So the next digit is 1. In this case, we're going to round down, isn't it? So that's 4 centimeters. Okay. So then pressure, the values I'm going to, they're the values I'm going to use in this formula then, isn't it? So pressure is force over area. Well, the force is easy enough. It's just 200. The area is pretty easy as well because it's a rectangle, isn't it? So area equals length times width, which is 5 times 4. That's 20. That's a bit of a scrawl. Let's just write that again. A length times width, which is 5 times 4, which is 20. So I'm going to be dividing 200 by 20. So cancel, cancel. That's 20 divided by 2. That's 10, isn't it? So that's 10 what? Newtons per square centimeter. Okay, that's 10. So just to be clear, the most of this, you're only going to get 1 mark for doing the actual division. At best. This is an estimate question, so 3 out of the 4 marks for this is going to be for rounding those numbers off, and then the other maybe 2, but certainly most of the marks are going to be for rounding off. If you don't round off, you're not going to get many marks from this question, if any at all. Question 11. The diagram shows quadrilateral ABCD. We're told that AD is 10, angle BAD is 30, angle ABD equals angle BDC, which is 90. All of those are marked on the diagram already. The ratio of length BD to DC is 1 to 2.4. Work out the length of BC. You must show your working. Okay, so the only thing that's not in text, so not on the diagram that's in the text, is this bit, the ratio part, isn't it? The ratio of length BD to the length of DC. So where's BD? BD is this length. BD is that diagonally, the straight line up the middle. That's BD. And DC, where's DC? That's this one. Okay, and they're in the ratio of 1 to 2.4. So whatever this one is, BD, I'm going to have to multiply it by 2.4 to get the other one, aren't I? Okay. So how can I get BD? I don't know BD though. But what I've got over here is a right angle triangle where I know one of the sides and an angle. So this looks like a job for trigonometry, doesn't it? This is a SOHCAHTOA question, right angle triangle question. So SOHCAHTOA. How do you remember it? That's how I remember it. Some people have a little rhyme or poem that goes with it or whatever. I just remember it like that as a word, SOHCAHTOA. Right, let's label up our sides and see which ratio we're going to be using. Now, I always start with the hypotenuse. It's easy to spot. If you can't, it's the one opposite the right angle. That's the H there, look. Okay. Then the other two sides are marked relative to the angle. So this side over here is on the opposite side of the triangle, so that's the opposite. And this one joins on, isn't it? This is the adjacent. Okay. So which ratio do I need? Well, I want to find BD, which is the opposite, and I know the hypotenuse, so I want the ratio with O and H. Another way of thinking about it is I don't know A, I don't want A, I don't want any of the ones with A in it. So any of the ratios with A I can ditch. It's going to be that one there, isn't it? So that tells me that the ratio is sine theta is equal to the opposite over the hypotenuse. Okay. Now, once I got that, it's just a matter of plugging the numbers in, isn't it? So sine theta. Theta is the angle. There it is down there. It's the 30. So that's sine 30 is equal to the opposite. that is the side BD that we're trying to find, isn't it? And that's BD divided by the hypotenuse, which is 10. There it is there, look. Okay, so the opposite was the yellow one, and the hypotenuse is the purpley one. All right, so BD over 10. So then rearranging that in terms of BD, that means that BD, what's that then? If I multiply both sides by 10, has the effect of moving that up there, doesn't it? So that's going to give me 10 sine 30. Okay, now in which case I'm going to reach for the calculator. But where is it? I don't have one. This is the non-calculator paper, isn't it? Oh dear. So what we're going to do here? Well, this is a case for having to know our exact values. So we've got sine 30. What is sine 30 equal to? Well, if you've memorized your table of values for exact values that you need to know sine, cosine and tangent for 0, 30, 45, 60 and 90. There are ways of memorizing this to make it a little bit easier for yourself, but you do need to know all these values. Now if you do, you'll know that sine 30 is a half. So that makes things a whole lot easier. That means that BD is just 10 times a half, and that is equal to 5. So BD is 5. Okay, so this is 5 centimeters then, and we know that the ratio of BD to DC, BD to DC, wasn't a very convincing B. We'll try that, make it a bit more B-ish. So BD is 1 to 2.4, but we now know that BD is 5. So scaling this by a factor of 5 and doing the same this side, we should be able to find the value of DC, shouldn't we? So DC is going to be 5 lots of 2.4. So times it by 10 and halve it. 24 divided by 10 is 12. So 2.4 times 5 is 12. Okay, and now that's going to be length of DC then. DC is going to be 12. Work out the length BC. Oh, they're having a laugh. Oh, but it's 7 marks, so wow. So we're not done. I thought we were finding DC, but no, the fun is not over yet. We need to find BC, okay? Where's BC? BC is this side down here. So switching our attention to the second triangle, BDC or BCD, can you see that's a right angle triangle of which we now know 2 sides. We know that's 5. We know that's 12, okay? I already know what the next one is. Do you? Because I know my Pythagorean triples. Do you know those? They're like a bunch that you need to, well, it's useful to know. There's like the 4, 5, 6 one, isn't there, which is a classic Pythagorean triangle. But 5, 12, 13 is the other one. So that one there I already know is 13. Okay? I kind of feel like I should really show it. It says you must show your working, even though I know it's 13. I'm going to have to go through the rigmarole of finding it, aren't I? So I'm going to say that BC squared is equal to 5 squared plus 12 squared, which is 25 plus 144, which is 169. So then BC is 169 square rooted, which I already knew was 13. Okay, but now I've kind of proved it using Pythagoras. So I should really say in triangle BCD using Pythag theorem. Okay, because I like to say what I'm doing before I do it. Okay, so there we go. So we had to do a bit of trig, then we had to do a bit of ratios, and then we had to do a bit of Pythagoras theorem. That was a whole lot going on in that question, but then it's worth 7 marks, so you know, not complaining. None of the steps were particularly hard, but it was kind of stringing a whole lot of things together to go from the beginning to the end. Okay, so yeah, 13 marks. Sorry, so 7 marks. Answer is 13. Question 12. The box plot shows the distribution of lengths in centimetres of 60 full-grown mice owned by a pet shop. Okay, so we've got a nice box plot here. Now, the first question says find the range. Now, if you remember, range is equal to the highest value minus the lowest value in your data set. Okay, now on your stem and leaf diagram, that is now on your box plot, that is going to be represented by the two endpoints of the whiskers here. We call these little lines that spread out whiskers. So where do those whiskers end? Well, the left-hand one is 7.0, so that's going to be the lowest value then, isn't it? That's 7.0. And then the top one is 7. What's that? Between 7.6 and 7.8, I've got 10 little divisions. That means each one of those must be 0.02 then. So 7.6, 7.62, 4, 6, 8, 7.7, 2, 4, 6, 8, 7.8. So that's going to be 7.64. So the highest value is 7.64 minus 7. I'm going to add an extra 0 on there to make that a little bit clearer. So I'm going to take away the 7 from the 0.64 then, basically, aren't I? And that's going to leave me with a range of 0.64 centimeters. Okay, so that's the range in their lengths. Part B says work out the number of these mice that have a length of at least 7.2 centimeters. Well, 7.2 centimeters coincides. Look, here's 7.2. That coincides with this line here. Now, that is actually the lower quartile, isn't it? Okay, this is Q1 here. Okay, the lower quartile. The middle stripe is Q2, or the median, and the next one is Q3. Now, Q1 lies 1/4 of the way through your data set. So 1/4 of the mice are going to be to the left of that point, which means 3/4 of the mice are going to be to the right of that value. So we need to work out the number of the mice that are of at least 7.2 centimeters. That means at 7.2 or bigger. So we want to know how many mice are to the right of that point. So if we've got 1/4 to the left and 3/4 to the right, then the number of mice greater than 7.2 is going to be 3/4 of my data set of 60. Okay, so we need to work out 3/4 of 60. So 1/4 of 60, 60 divided by 4, that is 15, and 15 times 3, that's 45. So we're talking about 45 mice. Okay, so we got 45 mice that are at 7.2 or greater in length. Sam owns 5 full-grown mice. Sam picks the third longest mouse and measures its length. Sam then looks at the box plot. Sam says, this mouse is 7.35 centimeters long. Therefore, the mice I own are longer than the full-grown mice owned by the pet shop. Give a mathematical reason to support Sam's conclusion. Okay. Well, Sam has got 5 mice, and he picks the third longest one, which is the middle one, isn't it? So if he's got like 5 mice, you know, so 1, 2, 3, 4, 5. They've got tails but no ears. Maybe I should give them ears. Anyway, so the middle mouse, he's basically picking the middle mouse, isn't he? So we would call that one, they look like more tadpoles, but anyway, they are meant to be mice. So yeah, he's picked the median mouse, isn't he? So this third mouse that he picks is of median length for his mice, isn't it? And then when he's measured that one and found that that one in the middle is 7.35, he's then comparing it with the box plot, and you can see the median of this one, Q2, is this line here in the middle. And now that measures, what's that there? That's 7.2246. That's 7.28, isn't it? Okay, so from the table, Q2 is 7.28. Okay, so his middle mouse is bigger than the middle mouse from the 60 that are in the shop. So you could say, comparing medians, on average, Sam's mice are longer, and that is 7.35 centimeters versus 7.28 centimeters than the shop mice. Okay, so that's a very valid argument mathematically, isn't it? He's compared the medians and he's found his middle mouse is longer than the other mouse. Now part 2 says, give a mathematical reason why Sam's conclusions may be unreliable. Well, I suppose we could, we don't know whether, if you have a look at his longest mouse, the one with the longest length, is that greater than the longest mouse that the pet shop owns? So you can say that on average, comparing medians, that they are. But maybe that longest mouse of his is shorter than the longest mouse in the pet shop. There might be a lot less than 7.64. Okay, so I think that's what I'm going to write down. I'm going to say Sam's mice may all be shorter than the longest mouse in the shop, which we know is 7.62. Sorry, 7.64. So really, we can say we've got insufficient data then, haven't we, really? Because we don't know. We don't know about the other mice. Okay, so we've got insufficient data. That could be that all the other mice are a lot shorter than the longest mouse in the shop. So then could you really argue that that his mice are longer if the longest one is in the shop? Okay, let's move on. Question 13a, write 3/11 as a recurring decimal. Now the easiest way to do this is just to do it by division. So if I'm going to take 3 and divide it by 11, and I'm going to see what I've got. Obviously 11 doesn't go into 3, 11 goes into 3 0 times, and it's got a remainder of 3, but I've got nothing currently to attach my remainder to. So I'm going to add a 0 there, so I've got 3.0, and then I can attach my remainder of 3 to that 0 that I've just attached on the end there. And then I'm going to repeat the process. 11's into 30. Well, 11's into 30 goes twice, okay, with a remainder of 8, isn't it? Okay, again, I've got nothing to attach that 8 to, so I'm going to add another 0. So I've got something to attach my remainder to. And I've got 11's into 80. 11's into 80, well, 7 11's is 77, isn't it? So it goes in 7 times remainder 3. Now again, I've got nothing to attach the remainder to, so add in another 0, then I can put the 3 in. And I think this is the point then it's going to start repeating, because then I'm going to get 2 with remainder 8 again, isn't it? Because 2 11's is 22, giving you a remainder of 8. So then if I added another 0, I'm going to attach the 8 to it, and then 11's into 8, going to go 7 times again. So it's just going to bounce around now between 2 7 2 7 2 7 and so on. So that's going to be where it starts repeating. So to write that as a recurring decimal then 3 over 11 is going to be 0.272727. We can show that as 27 with 2 dots on, one on the 2, one on the 7. That means that it repeats 272727. So that's my answer. 0.27 ... like that. Okay. With part B, we need to go the other way. We're given a recurring decimal and we're asked to write as a fraction in its simplest form. Okay, so the strategy to do that is we're going to let x be equal to our recurring decimal. I'm going to write 0.4. I'm not going to write with the dot, I'm just going to write with all the 8 so you can see what's going on a bit clearer here, and so on. So it's 0.488888888. Okay, now if I multiply that up by a factor of 10, then I'm going to get 4.88888, aren't I? So 10x, I'm just going to write above, 10x is equal to 4.88888888. Okay? So then if I then take one away from, and so on, and then if I take one away from the other, if I do this as a subtraction, then on the left look, I've got 10x take away x. That gives me 9x on the left. And then I've got 4.8888 take away 0.48888. Okay? Now obviously all of these 8s here are going to cancel with all of those 8s there. So really I've got 4.8 take away 0.4 to do. So 4.8 take away 0.4, that is 4.4. Okay? And then dividing both sides by 9, I'm going to get, so divide by 9, I'm going to get x equals 4.4 over 9. Now that's not quite a fraction, is it? Because I can't have a decimal numerator in the fraction. So just to tidy that up a little smidge, I'm going to times top and bottom by 10. And that's going to give me x is equal to 44 over 90. Okay. Before we finish though, going to see if we can cancel it down. So common factors of 90 and 44, well, they're both divisible by 2, aren't they? Is there anything more than 2 that I can use? 22 over 45, can you see any others? Don't think so. 45 has got factors, what, 1, 5, 9. I think that's it, isn't it? Okay, so that's my answer, 22 over 45. Question 14. Two solid ornaments are mathematically similar. The larger ornament is twice as tall as the smaller ornament. The smaller ornament has a volume of 50 centimeters cubed. Work out the volume of the larger ornament. Okay, so when you've got two ornaments that are mathematically similar, I'm going to have like a little blobby thing here and a bigger little blobby thing here. That means like one is an enlargement of the other, isn't it? Okay, so just a bigger version of it. Okay, and we're told in the question that the larger ornament is twice as tall as the smaller one. So if I measure this distance on one shape, compare it to this one, then one is going to be twice as bigger than the other. Okay, so in terms of their lengths, then these shapes are in the ratio of 1 to 2. And if they're mathematically similar, any length I measure on the shape, the bigger one would be twice as big as the smaller one. Okay, if you measure the matching length on it. Okay, and then the areas of those shapes, if you take any surface area or any flat area that you like on the shape, they're going to be in the ratio of the square of the lengths. So that would be like 1 squared to 2 squared, which is 1 to 4. And then the area, and then the volumes are going to be in the ratio of 1 squared are going to be in the ratio of 1 cubed to 2 cubed, which is in the ratio of 1 to 8. Okay, so that means the volume of the bigger one is going to be 8 times as much as the smaller one. Okay, so then the volume of the large ornament is going to be the volume of the small ornament, 50, multiplied by 8, because the volume of the large one is 8 times as much. And then 50 times 8, that is 400, isn't it? What's the units? Centimeters cubed. So that's 400 centimeters cubed. Question 15. Write root 20 plus root 45 in the form k root 5. Okay. Well, you can see both of these numbers have got a factor of 5 in them, isn't it? 20 has got a factor of 5 and 45 has got a factor of 5. So I'm going to rewrite them both with that factor pair showing. So 5 times what is 20 is 4, isn't it? So you can say that's 4 times 5 is 20. So that's the same thing as root 20 is the same thing as root 4 times 5. And 45 is 9 times 5, isn't it? So I can say that's the same thing as 9 times 5 under the square root sign. Okay, now when you've got two numbers under a square root sign multiplied together, you can actually break them up into two separate roots. You can say that's the same thing as root 4 root 5, and you can say that next one is root 9 root 5. Okay, now obviously 4 is a square number, so it does nicely square root. Square root of 4 is 2, so root 4 root 5 is the same thing as 2 root 5. And similarly, root 9 is a square number, so you can square root 9 and get 3. So root 9 root 5 is the same thing as 3 root 5. Okay, so now I've got 2 root 5 plus 3 root 5. And notice we've got the same thing here and here, which means we just simply add these numbers together. Okay, so you can collect them together a bit like you collect like terms together algebraically. If you had 2x plus 3x, you probably all know that was 5x. So 2 root 5 plus 3 root 5, that is the same thing as 5 root 5. Okay, and that's my answer, 5 root 5. So notice it's in the form k root 5, where k is equal to 5, isn't it? Just basically, it's in the right form. Question 16. In a group of 60 students, 40 own a smartphone, 27 own a tablet, and 8 own neither. A student is chosen at random from those that own a tablet. Find the probability that they also own a smartphone. You must show your working. Okay. Now the working I'm going to do straight off here is I'm going to draw a Venn diagram. I've done enough of these questions to know that is the key to this question. Okay. Did you think of doing a Venn diagram? Okay, so the Venn diagrams are great when you've got like two groups, you know, a group of students who could own one thing or the other thing or both things, and you don't have all the information. And a Venn diagram is a nice way of then sorting out what's what. Okay, so I've got my two groups here. I've got my group that own a smartphone and my group that own a tablet. I'm going to call S and T. Now, what can I put in here? And I've got my universal set. Now, my universal set contains 60 students. Okay, so altogether there are 60 students. Now there are going to be 40 students who have a smartphone, and then you're going to have 27 students own a tablet, and you've got 8 students who own neither. But the only thing I can put in straight away is this 8 in here, because there's an overlap, isn't there? Some of them have both, and because we don't know what the overlap is yet, it makes us hard to be able to work out what to put in each of the regions. So what we're going to do is we're going to put an X in there, because we don't know how many people have both. Okay, so I'm going to say that let X people have both, and then I can complete it, and then I can say, well, if there are 40 people who have a smartphone, of which X have a smartphone and a tablet, there must be 40 minus X that only have a smartphone. Okay, so that when I add on the X, I get 48 altogether. Similarly, if I've got 27 people who own a tablet, X of which also own a smartphone, then 27 minus X must have a tablet only. Okay, so now we've got something in each of the regions of our Venn diagram. And we know that universal set is 60. So if we add each of those regions together, it should tell us, or it should give us an equation in X that we should be able to go on to solve. So I've got 40 minus X in the S only section, plus X in the middle, plus 27 minus X in the T only section, plus 8 who have neither, and that's equal to everything in the universal set, which is 60. Okay, so can you see now we've got an equation in X. So what have we got then? We've got 40, 27 and 8 on the left in numbers, and we've also got a minus X, a plus X and a minus X. Okay, so grouping together the numbers, 40 plus 27, that's 67, plus 8, that is 75. So I've got 75 and I've got minus X plus X minus X. Well, those two are going to cancel each other out, aren't they? The minus and the plus, and that's going to just leave me with one other minus X. So 75 minus X is equal to 60. Okay, so just add in X to both sides and take in 60 away from both sides. So if I add X, I'm going to get 75 equals 60 plus X, and then if I take 60 away from both sides, then that is going to give me 15 is equal to X. Okay, now once I know that 15 is equal to X, then I know that that's the number that goes in the middle, and then so for S only 40 minus 15, that's 40, 30, 25, 25 there, and then T only 27 minus 15, that's 12. Okay, so now we know everything in every region, we can actually now then go and answer the question. And the question is, if a student is chosen at random from those that own a tablet, find the probability that they also own a smartphone. Okay, well, if they're chosen from the group that own a tablet, we're talking about everything inside the T group, aren't we? And we want to know the probability that if they're picked from within that group, that they also own a smartphone. So that given that they're inside that group, what's the probability that they're actually in this part of it, the overlap? Okay, well that's easy to work out. So the probability of well, I don't know if you know this, but you could say that's the probability that they're in S given that they're in T. Okay, this is conditional probability. That's how you write it down, and that's equal to well, how many students were in S given that they're in T? Well, altogether you got 15 plus 12. That's 27 students altogether. That's the denominator, isn't it? That's the number of students you're picking from, and 15 of them have a smartphone. So the probability that you get someone with a smartphone, given that they've got a tablet, is 15 over 27. So that's my answer, 15 over 27. Question 17, simplify fully 2x squared minus 50 all over x squared plus 7x plus 10. Okay, so we've got an algebraic fraction here that we're going to try and simplify. Now we're going to try and simplify it by factorizing as much as we can, and hopefully some of the factors that we find are going to cancel top and bottom, reducing the complexity of our overall fraction. Okay, so let's have a look at the top first. I've got 2x squared minus 50. Now the first thing I'm going to do is just going to factorize 2 out of both terms. Okay, so I'm going to take 2 out. That's going to leave me with x squared minus 25 on the top. Now there's further factorizing to do there, because x squared minus 25 is what we call the difference of 2 squares, isn't it? And with the difference of 2 squares, that factorizes into x plus the root of 25, x minus the root of 25. So I'm going to get x plus 5, x minus 5 on the top. Okay? Hopefully you are familiar with the difference of 2 squares. Now on the bottom we've got a quadratic, and I've got x squared plus 7x plus 10 that I want to factorize. Okay, now I always start with the number on the end, the 10 in this case, and think about what the factor pairs of 10. 10 has factors 1 and 10, 2 and 5, and that's it, isn't it? So it's either going to factorize into x plus 1, x plus 10, or x plus 2, x plus 5. And the way we work out what it is we have a look at the coefficient of x in the second term. So we want the factor pair that adds up to 7. So it's not 1 and 10 because they add up to 11, but 2 and 5 do add up to 7. So that is the pair that I want. Okay, so that factorizes into x plus 2, x plus 5. Okay, which is going to be the same over this one as well. Okay, so we're all factorized top and bottom now. Now we're going to look to see if we can cancel down at all. And can you see we've got a common factor on the top and on the bottom in x plus 5. So we can just simply scratch them both out. Okay, so they both cancel each other out. That leaves us with 2x minus 5 on the top over x plus 2 on the bottom. Okay, and that's it. That's as simple as we can make it, I think. Question 18, A, B, C and D are points on the circumference of a circle. EF is the tangent to the circle at D. Angle BDF is 70 degrees. The ratio of angle BCD compared to angle CBD is 5 to 2. Work out the angle CBD. You must show your working. Okay, so just reading through there. A, B, C and D are points on the circumference of the circle. So A, B, C, D. So if you've got 4 points on the circumference of a circle, do you know what that's called? It's called a cyclic quadrilateral. They have some properties that we might come in handy in a moment. EF is a tangent to the circle at D. Okay, that's also got some useful properties that we're going to come into at the moment. So that's my tangent. And then angle BDF is equal to 70. Okay, right, so what I'm going to do first off, I'm going to look at this angle down here, this 70 degrees. Now I did say earlier that yeah, tangents have properties when they touch circles like this, and one of them is the alternate segment theorem. So using alternate segment theorem. Now this is a show your working question, so you know you have to put these little nuggets into your answer to show that you know the rules that you're using. It's not good enough just to find the angles. You have to explain the process. So I'm using that rule to find another angle here. Now the alternate segment theorem is one of our circle theorems that we need to know. Now that says the angle between a tangent and a chord drawn at the point of contact, which is the 70 degrees that we labelled a second ago, is equal to the angle subtended in the alternate segment, which is basically if you subtend an angle off that chord, which this angle up here is, they're going to be the same. So that 70 degrees there has to be the same as this one here. Okay, so the green line is the tangent. I could say that this pink line here is the chord, and then the angle over there at A is the angle subtended off of that chord. You can see both its feet are at the end of that chord. Okay, so that one over there has to be 70 degrees. Okay, so using the alternate segment theorem, then I can say that angle DAB is equal to angle CDF. And that is equal to 70 degrees, isn't it? Okay, so we've got one part of the puzzle. Okay, now the next thing we're going to be doing, we've got a ratio that we need to use in a bit between BCD and CBD. So BCD, where's that? That's this angle over, running out of colours. What colour am I going to go for? I might go for pink again. So this angle over here, what's that angle there? Okay, we need to know that one, because once we know that, then we can use it to find CBD. Where's CBD? CBD. We can. It's that one over there then. Once we know that one, we can find that one over there, hopefully, because we got the ratio. Okay. Right. So now I can find that pink one that I first did. I can find this one over here using the fact that ABCD is a cyclic quadrilateral. So I'm going to write that down. ABCD is a cyclic quadrilateral. And what that means is, again, if you look at your circle theorems, in a cyclic quadrilateral, opposite angles sum to 180. So opposite angles sum to 180. In other words, angle DAB plus angle BCD must be equal to 180 degrees. Okay, now I already know DAB, it's 70, so 70 plus BCD is 180. Okay, so then taking 70 away from both sides, it's going to give me BCD by itself, isn't it? So BCD angle is equal to 110 degrees. Okay, so we now know that that's 110. And then finally, we said we can use this ratio down here that says the ratio of angle BCD to the angle CBD is in the ratio of 5 to 2. Okay, so BCD to CBD angle is in the ratio of 5 to 2. Okay, but we now know that BCD is 110. That's 110 degrees. Now, what do I have to multiply 5 by to get 110? Well, 110 divided by 5, that's 22, isn't it? Aren't I timesing that by 22? Okay, 22 lots of 5 is 110. So, because this is a ratio, do the same to both sides. So if I multiply the other side by 22 also, I'm going to get the size of angle CBD then, isn't it? So that's going to be 2 times 22, that's 44 degrees. Okay, so therefore angle CBD is equal to 44 degrees. All right, we did it. CBD, I found it. Good job. Yeah, so this is a 5-mark question. You're only going to get all the marks if you are clear about the rules as well as finding the angles. Okay. Question 19. The point 5, 7 root 2 lies on the circumference of a circle, center 0, 0. Find the equation of the circle. Okay. So I'm just going to quickly sketch this. I'm going to cheat because I'm rubbish at drawing circles. There we go. So there's my circle, and then just draw some axes through it. 1, 2. Okay. So the center of this circle is at the origin. So that's the origin there, 0, 0. Okay, and we know a point on this line which is 5, 7 root 2. Now, where's the point 5, 7 root 2? Well, root 2 is bigger than 1, so something bigger than 1 times 7 is definitely going to be bigger than 5. So it's going to be like somewhere up here, isn't it? Okay, so slightly higher up than it is along. So that's the point 5, 7 root 2. I don't know how that's important, but I just like to get my diagram as good as possible. Okay, find the equation of a circle. Now, the equation of a circle centered origin is always of the form x squared plus y squared equals r squared, where r is the radius of the circle. Now, the radius of the circle is this line here, isn't it? Okay. So basically, to find the equation of this circle, all we really need to do is to find the length of that radius. Okay. Now, you could take this radius and you could turn it into a little right angle triangle like this, and then that triangle, okay, is going to have sides 5, which is the x coordinate, and 7 root 2, which is the y coordinate then, isn't it? Okay. So then basically what we're trying to do to find the radius is to find the longest side of a right angle triangle. So this is a job for Pythagoras theorem then, isn't it? So using Pythagoras theorem, then what am I going to do? The square on the hypotenuse, r squared, is equal to the sum of the squares of the other two sides. So it's going to be 5 squared plus, just going to do this in brackets because I'm going to have to do this in 2 parts, 7 root 2 all squared. Okay. 5 squared is easy enough, that's 25. 7 root 2 all squared, when you square something which has got 2 parts in it like that, that's the same thing as squaring each one separately. So it's going to be 7 squared times root 2 squared. So you're going to square both parts basically. Now 7 squared is 49. Root 2 squared is just 2. So I'm going to get 25 plus 49 times 2. 49 times 2, that's 98, isn't it? So I've got 25 plus 98, and 25 plus 98, that is 123. Okay? Now, I don't need to square root now to find r, because remember the form of the equation is x squared plus y squared equals r squared, and that's what I found. So there's no need for me to then square root this to find r, because actually what I was looking to do was find r squared, so I can complete my my equation. So there's no need to do any further work. I'm just going to write down the equation now. X squared plus y squared equals r squared, which is 123. There we go. Job done. Question 20. X squared minus 2y is 5 and 4y plus z is 7. Write z in terms of x. Give your answer in its simplest form. Okay, so we've got 2 equations here. One involves x, or x squared I should say, and y, and one involves y and z, and we want to make one that involves x and z. So what we want to try and do is kind of eliminate, to link them together and kind of eliminate y in the process. Okay. Now notice that that 4y is twice as big as that 2y over there. Okay, so what I'm going to do is I'm going to take equation 1, this first one, and equation 2, let's call that the second one. Let's take the first equation and multiply it by 2. So if I take equation 1 and I multiply it up by a factor of 2, what am I going to get? I'm going to get, that gives me 2x squared minus 4y is equal to 10. So just doubled up everything, haven't I? Okay. And then taking the second equation and rearranging it. So rearranging equation 2, I want to make 4y the subject. So 4y is going to be equal to, so if I just take 7, if I take z away from both sides, from there, look, they're going to cancel, and they're going to get 7 minus z then on the bottom, aren't I? So 4y equals 7 minus z. Okay. Now you'll notice now I've got a 4y here and a 4y here. So what I'm going to do is I'm going to take what 4y is equal to, and I'm going to plug it in where the 4y is in the first equation. Okay, so let's just call this one equation 3, equation 4, and say substitute equation 4 into equation 3. What's that going to give me? So I'm going to basically replace that 4y with 7 minus z. So I'm going to get 2x squared minus, I'm just going to put it in brackets, 7 minus z is equal to 10. Okay. Then remember we need to write z in terms of x, don't we? Okay, so we need to make z the subject now. So z's embedded in that bracket at the moment. So let's remove the brackets. So 2x squared, that's going to be minus 7 minus z is plus z, isn't it? Because basically I've got minus 1 lots of minus z, and minus 1 times minus z is plus z, and that's equal to 10. Okay. Then what we're going to do is going to add 7 to both sides, and we're going to take 2x squared away, and that will leave me with z by itself then, isn't it? So add in 7, it's going to give me 17, and then taken away 2x squared, then I've got z is equal to 17 minus 2x squared, and that's my final answer then, isn't it? Because I've got an expression for z in terms of x, which is what I was asked for. So there we go. Z equals 17 minus 2x squared. Question 21. AOB is a sector of a circle, centre O and radius 10 centimetres. The area of the sector is 40 pi centimetres squared. Work out the perimeter of the sector. Give your answer in the form a plus b lots of pi, where a and b are integers. You must show your working. Okay. So we're starting off knowing the area. Okay, now what is the formula for the area of a sector? Okay, well, the area of the sector is going to be theta over 360 degrees, where theta is the angle at the center of your sector, multiplied by the area formula of a circle, which is pi r squared then, isn't it? Okay, now we don't know the angle at the moment. Hopefully we can find that from what we know in a minute, but we do know what this is equal to. We know that this is equal to 40 pi because it tells us in the question. Okay, so hopefully from this we should be able to work out what theta is. Now we know what r is, don't we? We're given that in the question. That's 10. Okay, so let's sub that in. So theta over 360 times, I'm going to get 10 squared lots of pi, aren't I? And that's equal to 40 pi. Okay, I think what I'm going to do is I'm just going to cancel the pi's off. You see, like, I've got pi on here and pi on here because they're both factors, aren't they? So I can just multiply them out. Okay, because these are common factors, I can just simply cancel them out like that. Okay, that simplifies things a little bit. So then I've got 10 squared, which is 100, times theta over 360, and that is equal to 40. Okay, I think I might try and simplify here a little bit. Just divide them both by 10. I'm going to get 10 over 36, aren't I? That's equal to 40. And then maybe dividing both sides by 10, I can get rid of that other 0 there and cross that one out. So now I've got theta over 36 is equal to 4. And then I can cross multiply or multiply both sides by 36. And that's going to give me the value of theta. Theta is equal to 4 lots of 36. What's that? 36, 72, 144. Okay, so that's the angle at the center of my sector. Now I know that, I can then work out the perimeter, can't I? Because I know the perimeter is equal to 10 plus 10 plus my arc length, isn't it? Okay, it's going to be 10, 10, and the arc part here added together. That's the perimeter, isn't it? So 10 plus whatever the arc is. Okay, so how long is the arc? Well, let's find out. So the arc is equal to, well, the length of an arc is theta over 360 multiplied by the circumference formula, which is 2 pi r, isn't it? Okay. Now I've worked out what theta is. That's 144. So I've got 144 over 360 times 2 pi r then, which is 2 pi times 10 then, isn't it? Okay. I'm going to cancel that 10 into that 10, that 0 on the end there. Okay, so it leaves me with 144 times 2 pi. Well, 144 times 2, that is 288. So that's 288 pi over 36. Now I'm hoping 236 goes into pi. Does it? Yeah, it does, because like 36 doubled is 72, double again is 144, and then double it again is 288, isn't it? So doesn't it go in 8 times? I think it does. 36 doubled, 72 doubled again, which is times 4, 144 doubled again is 288. So it goes in 8 times. So I can cancel that into that and leave myself with 8. Okay, so then that is going to leave me with 8 pi altogether. Okay, so then my perimeter is going to be my 10 plus 10, which is 20, plus the 8 pi I found for the arc length. Okay, so there we go, that's it, 20 plus 8 pi. That's in the form of a plus b lots of pi. A is 20, b is 8. Okay, so we're done, aren't we? Good job. Question 22. N is a positive integer. Prove that 2n plus 1 multiplied by n minus 3 multiplied by n plus 2 plus 3n lots of n plus 7 is always even. How are we going to do that then? I suspect, well, probably the first thing to do is to multiply it all out and see what we get. Okay, I think that's where I'm gonna head off to. So we've got like a triple bracket here, haven't we? So we've got a triple bracket here, plus some other gubbins at the end that we can add on once we've multiplied out the triple brackets. So it's going to be a bit of work, but it shouldn't be. Oh, we'll get there, won't we? Okay. So when you're multiplying out 2 brackets, just kind of leave one where it is first. So I'm just going to leave the 2n plus 1 to kind of hang in there, and I'm going to multiply out the other 2. Okay, so n minus 3 times n plus 2. So first inside, outside, last, and all that. I'm going to get n times n, which is n squared, minus 3n plus 2n minus 6. Okay, and then I've still got my, maybe I should just multiply this out while I'm at it. So that's going to be 3n squared plus 21n. Okay, let's just tidy up that middle bracket. So 2n plus 1 lots of n squared minus 3n plus 2n, that's minus n, isn't it? Okay, and then I've still got these 2 terms on the end. Right, so now we're ready to multiply out the second bracket. So I'm going to multiply out everything by 2n first off. So I'm going to multiply this, this, and this by 2n. So 2n times n squared, that's going to be 2n cubed. 2n times minus n, that is minus 2n squared. 2n times minus 6, that's minus 12n. Okay, we're done, aren't we? And then we switch over to multiply everything through by 1. So I've got 1 times n squared, 1 times minus n, and 1 times minus 6. Just going to write it down underneath in the right places so that I can then add it up afterwards. So 1 times n squared, that is n squared. 1 times minus n is minus n. and 1 times minus 6 is minus 6. And we've still got those two terms on the end, so I'm going to add those on as well. So I'm going to get 3n squared plus 21n. So you can see I've kind of done it in columns, and that's so I can just add it up a little bit easier in the end. So looking at my first column here, look, I've just got a 2n cubed. And then my next column is my n squared term. So I've got minus 2n plus n squared plus 3n squared. That's going to give me 2n squared altogether. Okay, and then I've got my n column of things. So I've got 21n, take away 12, take away n. So what's that? 21, 28, isn't it? 8n. And then minus 6. Right, now I can see that each of my 4 terms is an even number. So that means I can factorize out a 2 out of each of them, can't I? So if I take a 2 out of each of my terms, that's going to give me n cubed plus n squared plus 4n minus 3. Okay? And so if that is the case, you can see that it doesn't matter if what value of n is. If it's a positive integer, this part here is always going to be an integer. Okay, and then if you times it by 2, then it's going to be an even integer, isn't it? Or, yeah, that's it. So whatever n cubed plus n squared plus 4n minus 3 happens to be, when I double it up, it's going to be an even number. Okay, so I'm just going to write that down, that as n is a positive integer, it means that n cubed plus n squared plus 4n minus 3 has to be a positive, well, it has to be an integer too, doesn't it? Is also an integer. Okay, so because I'm not dividing through by anything, I'm just kind of squaring a whole number and then adding whole numbers together. I'm not going to get anything other than a whole number, am I? Okay, so if that is the case, then multiplying an integer by 2 always gives an even number. Therefore, 2n plus 1, n minus 3, n plus 2, plus 3n, n plus 7 is always even. Okay, I think that's good enough. Now, probably the algebra by itself is probably enough to get the 6 marks actually, but yeah, I'm just stating my logic in words underneath. Just make it clearer for myself, I think, and to the people watching. So yeah, so you'd probably get all the marks just to get to this point. But you know, this is an explanation about why that does prove that it's always even. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.